Hey guys, Mr. Riz here to help you out with the 1.5 guided notes. So let's get into this. So let's start a little warm up here. So we're looking at linear functions. So let's see what you guys remember here. I got a couple questions. If you guys want to read them and pause them, we'll go over the answers here. All right, number one here. Which line of these graphs are functions here? That would be line R, line S, and line U. Line T is not a function because it does not pass the vertical line test. It's a vertical line. It has domains that have multiple range values. All right, find the coordinates. So hopefully this wasn't too bad. A is at 0, 1. The most common mistake is people mixing that up. I might say 1, 0. All right, B is at 2, 3 over 2 up 3. And C is at 5, 6 over 5 up 6. Now find the slope of each line here. We got line T is a vertical line. Vertical lines have a undefined slope. And line S is a horizontal line that has a 0 slope. Every other slope, we just count rise over run. Hopefully that wasn't too bad. All right, here are learning standards. Pause if you want to read them in detail. But big thing that you guys need to know are learning goals here. You want to be able to, by the end of this, be able to graph linear functions and then also graph linear inequalities with two variables. Okay, so to graph a function means representing all ordered pairs that are true for that function. So technically a line is not a line, but a series of small points all connected that make the statement true. There's a lot of different ways that we can graph a linear function. We're going to go over several of them. All right, so one way that we can graph is by using a table. So if we got x plus 3y minus 6 equals 0, what we probably would want to do first is to go through and get the equation y by itself to be able to make a table. All right, so let's work on that together since we actually are now kind of doing more mathy math stuff. All right, so if we were going to get the y by itself, we want to minus the x over from both sides. And we'd get 3y minus 6 equals negative x. We'd want to add the 6 over. So we get 3y equals negative x plus 6. Ooh, there we go. And then divide by 3 to get the y by itself. Now, when you divide by 3, technically you divide everything or both sides by 3. So we get y equals negative x divided by 3 is negative 1/3 x. 6 divided by 3 is 2. All right, so we got the y by itself. Then the next thing we would want to do is to go through and plug in these x values to get their corresponding y. So we would have at negative 1/3, if we say x is negative 6 in our table here, plus 2. So let's see, negative 1/3 of negative 6, that'd be a positive 2. 2 plus 2 would give us 4. So that means there's a point at negative 6 up 4. We plug in negative 3 into the table. Negative 3 times negative 1/3 is a positive 1. 1 plus 2 is 3. So at negative 3, we're up at 3. We plug in 0. 0 times negative third is 0. 0 plus 2 is 2. So at 0, we're at 2. You can start to see a pattern here. All right, negative 1/3 times positive 3 plus 2. That'd be negative 1 plus 2. That'd be a 1. And then 6, if we plug in 6, you can imagine here with this pattern, we get a negative 2 plus 2, which would be at 0. Okay, so you see we can make a table, and each table is technically just a set of ordered pairs. Let me clear the drawings and move on to the next slide. Boom, 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 here we go. And so then we go through and plot those points. So once you guys give this a second here, try to graph this one by using the table. So go ahead, pause the video, try it on your own. I got a table set up for you. Graph by using points on the table. All right, let's check to see if we did this right. So the first thing we want to do is to get the y by itself. So let's subtract the 6x over. We get 2y equals, now be careful, it's going to be 10 minus 6x is not 4x, it is negative 6x plus 10. That has that variable, that doesn't. We divide by 2, we have y equals negative 3x plus 5. Okay, so now let's plug in some numbers here. All right, if we are going to plug in -1, so what is -3 times -1 plus 5? -3 times -1 is a +3. 3 plus 5 is 8. So at -1, we're up here at 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to just guess it. It's up here. All right, let's plug in 0. So -3 times 0 plus 5. That'd be 0 plus 5 is 5. So at 0, we're up at 5. Okay, keep the pattern going. Hopefully you start to see a pattern here, because that's the point of linear functions. We plug in 1. All right, -3 times 1 is -3. -3 plus 5 is 2. So at 1, we're at 2. And if we plug in our last one here, -3 times, now be careful, that table set is 3. Let's see, that would be -9 plus 5 would be -4. So at 3, we're at -4. We use our best skills to connect the dots. Not looking straight at it, but there we go. There would be the linear function. Hopefully not too bad. Now, that's not the only way to graph linear functions, but it's a decent way. It's technically what all the computer programs do when we look at Desmos. It's just easier for them because they're computers. They can do it real quick. Now, another way that we can graph a line is by looking at the x-intercept. Remember, a line is straight. So if we get 2 points on the line, we can just get a ruler to connect the rest of them. So 2 points that are easy to find are the x and y intercepts. So to find the x and y intercepts, what we're going to do is basically the same step, but depending on the variable. So if we want to find the x-intercept, what we're going to do is take the original function, 3x minus 2y equals -12. We're going to make the y equal to 0. So an easy way to remember this is if you are getting the x-intercept, you're solving for x. So you get rid of the y, make it equal to 0 technically. And let's see, that would be 0, it would go away. So we get 3x equals -12, and x would equal -4. Now on the other side here, the y, we do the exact same thing. We start with the equation. Right, this is for the y-intercept. But this time we're going to make the x equal to 0, and we're going to solve for y. Okay, so x-intercept, you solve for x. Y-intercept, you solve for y. So that goes away. We get -2y equals -12. Divide by a -2. Y equals a +6. So that tells us the x-intercept is -4. The y-intercept is +6. And then if we think about it, technically, the x-intercept is at -4. That means we have a point at -4, 0. So -4, 0 is the x-intercept. And then the y-intercept is at the point 0, 6. One thing to remember here is the x-intercept, the x number goes there, the y-intercept, the number goes in the y spot. So 0, 6. I think that's right above here. And then all we need to do is to take out a ruler to draw a nice straight line here. Actually, no, I don't want to do it. Can I do this? I'm going to kind of mess around with things. Double arrow, look at that. I should probably just do that more often. There's our nice straight line that we got going on. Okay. 2 points. So this one's a little bit quicker than making the table. Now keep in mind, you only get 2 points that are on the graph, but sometimes you can get some other clear indications. So I would assume that the point here, -2, 3 would be a solution as well. You can go the other way. That one is a quick way with only finding 2 things. And this is great if we have it in standard form. All right. So how can we check to see if a graph is correct? A couple different ways that we can do that. We can plug it into Desmos, see if it matches. Another thing too is we could just pick another value point and plug it into the equation to see if that solution is correct. All right, now here's probably the best way of graphing a line because it not only tells us like multiple points, it's also pretty quick to do. It does take some skill and understanding what it means. So typically we look at an equation and we get it into slope-intercept form. That's the classic y equals mx plus b. So we have the equation here where y is by itself, then we have something x plus some number. Now in this case, our m which represents our slope, is right here, is the number next to the x, and that is 3 over 2. And then our b is what's added at the end. Technically, we are adding a -4. So our b is -4. What we want to do first is to plot the b, which is the y-intercept. This is slope-intercept form. Our intercept is at the end. Just because it's at the end, doesn't mean anything. It means it's going to be the first thing we do here. So what we are going to do here at -4, we're going to put our point. So this is our starting point. Then after that, we're going to use the value of the slope to plot the rest of the points. Now, if the slope is 3 over 2, that means we're going to go up 3 and right 2. So positive to the right, up, 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 and to the right. So we do that, we should be getting a secondary point. So I see my colors here. All right, if we go up 3, right 2, we're going to be right here, and that is the point 2, -1. Now, what we need to do is just keep that going until we get all the way across the end. So I'll go up 3, right 2 again, and plot our third point. I want you guys to keep going until you get to the end of the graph. Also check the other way too. Could you go the complete opposite way, left 2, down 3, and get the point on the graph? That way we get as many points that are on our graph, and then all we need to do is to plot a nice straight line through those. Here's our equation. Oh, I forgot the last couple of points here if you want those. So from that second point to -1, we're going to go up 3, right 2, keep that slope going. We're at another point here, 4, 2. Okay, so that is graphing linear equations. So anything we have an equal sign. The next thing we're going to look at are linear inequalities. So these are greater than or less than, or greater than or equal to, or less than or equal to. So with the linear equality, it's very similar to a linear equation, except for we're dealing with two things. We're looking at a boundary, which is going to be kind of like our line. Now this boundary is going to be either solid if it's greater than or equal to, or less than or equal to, or dashed if it is just less than or just greater than, no line underneath. Okay. The other thing that we want to look at here is the shaded region. Because we are dealing things that are greater than or less than, our points are not just going to be on a line, but points that are true are going to be either above it or below it. So that half plane that we're going to be shading is either going to be above or below the line. And there's a couple different ways that we can find that out. So we're going to be looking at what we were just talking about. Closed half planes have the greater than or less than or equal to signs. Open planes are the ones. Open planes are going to be dotted. These ones are going to be solid. The constraint is what we're going to check at the end to make sure, are we shading the side or are we shading the other side of the line? So let's talk about how do we graph this here. We got 12 minus 4y is greater than x. Okay, so the first thing we want to do is to get the equation by itself, get the y by itself to find our boundary. All right, here we go. So we're going to take the original equation, 12 minus 4y is greater than x. And what we are going to do is we're going to minus the 12 over. And we get -4y is greater than x minus 12. And then we're going to divide by -4. So you got to remember a couple things here. We get y, and we get -1/4 x plus 3. Now in this case here, technically what's going to happen is this symbol is going to switch. Remember, when you're solving inequalities, you multiply or divide by negative, you have to flip the sign. So in this case, we're flipping the sign. All right, now what we're going to do though on our graph is to treat this boundary the exact same that this was an equal sign. So we're going to start out graphing our equation the exact same way that we graph just y equals -1/4 x plus 3. We do the same thing. We start with our y-intercept, we use their slope. Then we look at the symbol, and because this symbol, now the notes say it's greater than, technically it becomes a less than, but either way, since it doesn't have a line underneath, we're going to make sure that it is dotted or dashed, okay? We are not going to make this a solid line. All right, so now let's get to the graphing point here. Oh, my drawings again. So let's go through and plot our graph. So we got negative 1/4 x plus 3. All right, let me write that original equation on here. There we go. There's my pen. Y is less than negative 1/4 x plus 3. All right, so we're going to start up here at 3, right? That's our y-intercept. And then we're going to use the slope, negative 1/4, down 1 over 4. That's about as far as I can go that way. Go the opposite, up 1, left 4. So far, the exact same as a regular line. Now, instead of making this line solid to connect the points, since we have just a less than symbol, I'm going to make it dotted. Okay, so there's the first half that you guys need to do. All right, the next step, the last step is like, okay, well, do I shade above or below? Which side am I going to be shading? In order to do that, what we need to do is to test a point. You can pick any point as long as it's not on the line. Pick a point. We could pick, 1, 1. We could pick 2, 4. We could pick -6, -6. We can pick any point that we want. I think an easy point to test is right there at 0, 0. It's usually mathematically the easiest one to figure out. So we're going to take this original equation of y is less than negative 1/4 x plus 3. We're going to plug in 0 for y, and we're going to plug in 0 for x. And we're going to see whether this statement is true or not. So we get 0 here is less than, what's negative 1/4 of 0 plus 3? Well, that'd be 3. And we're going to figure out, okay, if that point there, is that true or false? Since 0 is less than 3, we are going to shade that side of the graph. If 0 was not less than 3, if we got a false statement, that means we need to shade the other side of the graph. Okay, so we always pick a point and test it out. So one thing to think about, like with this, like on a test, what I'm going to be grading here is a lot of small values. Okay, I'm going to check. Do you got the right y-intercept? Do you have the right slope? Did you pick the right kind of line? Is it solid or dotted? And then did you pick or shade the right side? So you can see a problem like this could easily be 4 points. Let's keep this going here. Let's have you guys try this one on your own. Okay, so we got x plus 3y is less than or equal to 8x. You want to give this one a shot? Pause the video now. Try it on your own. Okay, let's go over this here. So what we need to do is take the original equation, 9 plus 3y is less than or equal to 8x. We're going to minus the 9 from both sides. We get 3y is less than or equal to 8x minus 9. And then we divide by 3. And we're dividing by positive 3, so the sign does not change at all. We get this lovely fraction of 8/3 x, then minus 3. So our equation is y is less than or equal to negative, or not negative, but positive 8/3 x minus 3. But keep in mind, we're going to use the equal sign as our boundary. Clear all my drawings here, go to the next slide. So let me write that down. I'm always surprised like how quickly I can forget this. Y is less than or equal to 8/3 x. Gosh, was that plus 3 or minus 3? Oh, can't remember. Can go back? Minus 3. Okay, there we go. Maybe I should leave it on before. Okay. So let's dot that. So we're going to start here at negative 3. And then we're going to go up 8 over 3. Oh, man. Okay, that's about all we can do on this graph here. We're going to connect the dots. And this time we are making it a solid line. And it is solid because it's a less than or equal to. All right, next thing we want to do is pick a point. Remember, you could technically pick any point as long as it's not on the line. If 0, 0 is available, pick it. Okay. All right, 0, 0. We're going to plug 0 in for y and 0 in for x. And we're going to solve this here. 0 is less than or equal to negative 3. That is not true. So since 0 is not less than or equal to negative 3, we are not going to shade the side that 0, 0 is on. We're going to shade the opposite side. There we go. Okay, hopefully that wasn't too bad. Okay, let's see. So Think about this here. Is 3, -5 a solution of the inequality? One way that we could check here is to take the y is less than or equal to 8/3 x minus 3 and plug in the values. So that'd be like somebody maybe extra special decided instead of doing 0, 0, they want to plug this in. And all we got to do is to check is 5 from the y, is that less than 8 times 3 times 8/3 times 3 minus 3? Let's see, that would be 5 is less than 8/3 of 3 is 8. 8 minus 3. So we get 5 is less than or equal to 5. That is true because 5 is less than or equal to 5. And that is a solution. Yep, it's on the line. And since we have a solid line, it counts. All right, so we got a couple story problems here to kind of expand our knowledge on this, make sure we understand this here. So Malik's algebra teacher determines semester grades by finding the sum of 70% of the students' test grades average and 30% of the students' homework grade average. Malik wants a semester grade of 90% or better. Write and graph the inequality that represents the constraint of test grade X and homework grade Y. So 70% X, 30% Y, we want a total of 90%. Okay, so, go back. That's the exit ticket. Okay, so how could we do that here? Well, let's think about what percentages are. Percentages are decimals, right? And we're going to be adding the two grades together. So what we can do here is to say, oh, really get messed up here. X is the homework or test grade. So we can say 0.70x plus 0.30y has to be, if he wants a grade of 90% or better, greater than or equal to 0.90. Okay. I always say, now technically we would get the exact same or an equivalent line if we use 70 and 30 instead of 0.70 and 30, and same thing with 0.90. I always think if I see a percentage though, I'm going to change that to a decimal. Okay, so if we had to get the y by itself, or we would minus the x over, it's like messing up here, 0.30 y is greater than or equal to, okay, getting nervous here because it's kind of glitching, 0.70 x. You know what I'm going to do? I'm going to turn my pen off, and then I'm going to show you guys a trick though. Thank you for watching this all the way. Let's do clear all my drawings. Let's talk about a tool that we should get used to using. Desmos. All right, so we know if we needed help graphing, we could have typed that in. In fact, we can just type in the equation, 0.70x plus 0.30y equals 0.90. We get that line. Okay. Now, here's where we can kind of use the new skill. If I get rid of this here, we go to our tool here, we do have a greater than or equal to, and that will actually shade. And to kind of show you too, there's a nice solid line here, right? If I use just a regular greater than symbol, it becomes a dotted line. Use Desmos as a tool to help you out. If you're worried about that small little detail of what's what, get through, check on Desmos. All right, we do have the exit ticket there, but remember what you guys are going to be working on are the McGraw-Hill CYUs. Thank you guys for watching. If you guys have any other questions, make sure you ask, but this actually wraps up chapter 1. So we'll be getting ready for the test, and you guys have a great rest of your day. Thank you for